till now we have seen the singly linked list. While reversing the singly linked list, we observe that having only one pointer makes it a bit difficult to reverse the list or to access the list from end to the beginning. Okay. For example, try printing the list in the reverse order. If I give you a singly linked list and if you want to print it in the reverse order, it requires quite a bit effort. Okay. So please try that as homework and then we can discuss it next time. Okay. But let's see how we can do it easily if we have a doubly linked list. Okay. So doubly linked list is going to give us an added feature where accessing the list in the reverse order also becomes convenient. So now, just like we defined the node for singly linked list, I'm going to have doubly linked list node definition. Okay. And what it will have inside is it will have a data value that it stores, and it will have pointer to node. So it will have DLL node pointer, and will call those pointers as the next pointer as well as the previous pointers. Okay, so that's the change that is going to happen in the node. So when we had previously a singly linked list node, we had a value, okay, and then we had this next node which was pointing to the next node, but now in addition we have also the previous node here. Okay, that's the difference that is going to happen. And now I'm going to define my doubly linked list. All it will have is pointer to a node, and let's call it the head node. Okay, so if you compare this against the singly linked list, it looks quite similar. Okay, so let me check where is this is where we had the singly linked list. Okay, so we had so just see them side by side. Okay, there is singly linked list node which has value and pointer next. There is doubly linked list node which has value but pointer next and previous, and we had singly linked list node where we had head, and we looked at other implementation which was using tail as well. Okay, but if we can do even without tail, and here we also have the head, and then we'll see can we have an implementation where we can use the tail pointer as well. Okay, first let's just get started with the head. Now just because we have two pointers, does it really change the operations? It doesn't. Okay, because when we have defined the singly linked list, we had certain set of operations, and with doubly linked list we are going to have same set of operations. Now only thing that is going to be different is that we have two pointers per node, and it might help us in efficient navigation of the list. Okay, so let's see what we can do. So first operation is create new. So what they should do is they should just create an empty list. So all that I will do is I'll set my head to null. Okay, that's how I define a new empty list, and let's cross check it with the singly linked list. Okay, is that the way we did? Yes, that's the way we did. Okay, so again exact same implementation. Now let's try to add element at the beginning. Okay, so add at the beginning, and I have the doubly linked list node pointer, and let's call it new node. Okay, so most of the things are going to look quite same as the singly linked list, but there will be few differences. Okay, so what should we do? We should first ask the question, what is the next pointer of our head node? So for example, if our say list is empty, then our head will be null, right? So again, look back at what we did. Okay, so we said that new node dot next was going to be head. We'll do the same thing here, right? But let's just add a case if the list is empty. Okay, so if it's empty is true, in that case what we have to do, then it's simple. We will say that our head is equal to the new node, and then we are done. Okay, and then we can just return from here. Okay, so let me add the return statement here. Okay, but if that is not true, if list has at least one node before, then what we should do? Well, then it's clear what we should do. Oh, here one more thing we have to do. Head is equal to new node, and then new node dot previous should be null, and also new node dot next should be set to null. All those things we have to take care of, so that our list is well formatted. So we have to do three things: head equal to new node, and new node dot previous is null, and new node dot next is null. Okay, so now we have list with one node. If this is not the case, if list already has some elements, in that case what we should do? Well, in that case, first we should say that our new node dot next will be equal to our current head, and our new node dot previous will be equal to null, because this is going to be the first node in our list. And then we should replace the head node. So we should say that our head is equal to the new node. Okay, and there is something else that we have to do. We have forgotten to do that. Okay, so before we replace the head, we should look at the current head, and we should say that, oh, the head dot previous should be equal to the new node that we are inserting. Okay, so for the new node next head, for the head that we have previous is new node, and for the new node previous we have to set it to null, and our head is new node, and then we are done. Okay, so that's how the add at the beginning will look like. So let's see how this will work. Okay, so let's say I've started with a list. Let's call it L. It has its head pointer. It is pointing to null because I have created the empty list. Okay, and now let's have operations one after the other. Let's say I want to add 10 at the beginning. Okay, so when I want to add 10 at the beginning, I'll start from here. I'll ask question, is my list empty? My list is empty because my head is null. In that case, what is going to happen is head is going to be equal to new node. So as an input, I have received this particular node. Okay, I have this node which has previous pointer, next pointer, and I have value here which is 10. Okay, typically when the client code sends you this particular node, what it should do is it should set these values to null. Okay, ideally that's the way it should be, but we won't assume this. Okay, so now what is going to happen is the list is empty. So we will say that our head is new node. So head, instead of pointing to null, now it is going to point here. And now we will say that new node dot previous is null. So new node dot previous is null, and we are going to say that new node dot next is null. New node dot next is null. So ideally they should be set to null beforehand, but if they are not, we are setting them explicitly. And once we finish it, we are returning. Okay. And now let's add one more element to this list. So I want to add 20 at the beginning. So I give one more call, add B with 20. So now here I have one more node which contains 20. Here is the previous, here is the next. Ideally both of them should be pointing to null. But again, our code is not going to assume that. We come here and ask question, is our list empty? Our head points to node 10. So our list is not empty. So this conditional block will be skipped. And then what we'll do, we will say that, oh, new node dot next is equal to head. So this is the new node. For this new node, what we will say is that the next, instead of pointing to null, this next should point to this particular node. Okay. And then we are saying that head dot previous. So this is our head points to this node. Head dot previous, instead of now the old value, it should point to our new node, And then we are saying that new node dot previous should be null. So new node dot previous should be null. That is something we have taken care of. And head is equal to new node. So head is currently pointing to 10. So we are going to remove this, and head is going to point to 20. And now our list is head node is 20. Because this is the first node, there is no previous node. And then for 20, next node is 10. For 10, the previous node is 20. And then for 10, there is no next node because this is the last node in the list. So that is how add at the beginning for the W-linked list is going to work. It is quite similar to the way we did add at the beginning for our singly linked list. So just compare these two, okay? In case of singly linked list, we had to deal with only the next pointer. So comparatively things were quite simpler, but here we have to deal with the previous as well as the next pointer. So we have to be a bit more careful. So this is the add beginning function. And if you can see, we are doing it in constant time. There are constant number of operations, okay? Next, we will see how to do add at the end.